curves, you kind of start with the area of a sector, which just means a portion of a curve. Well, the area of a sector of a circle, got radius r, and theta is the angle there of your sector. Does anybody know what it is? Well, area of a full circle is pi r squared, right? But I'm not talking about a full circle. I'm only talking about a portion of a circle, which we can get that by thinking about the portion of this circle that's swept out. Isn't that one way we can think of it as a ratio? It's theta over 2 pi is what the part of the circle so I've got pi r squared, but then I've got to multiply it by the portion of the circle. So whatever theta is divided by 2 pi. You know, if it was, if I was talking about theta was pi units, half of a circle, I'd have pi divided by 2 pi, which is a half. But no matter what theta is divided by 2 pi, that'll give you the portion of the circle. Well, of course, what happens there? Pi's cancel, and here's what it is. Area of a sector is 1/2 r squared theta. So if you take half times the radius squared times the theta angle, that gives you area of a sector. Okay? Well, here's how that's useful to us. So let's say we have some weird little polar curve. Doesn't really matter what it looks like. Let's make it really wild. Okay, that's our polar curve, and we're going from A to B. So usually when you do angles, you know, you go counterclockwise, right? And so we're going from this angle right here all the way through that angle there. And so I want to know what is that area right there. So this is at theta equals A, and this is going to theta equals B. Kind of sweeping. It's kind of a sweeping sort of thing. That's the area I want to know. Well, where the sectors comes in is I'm going to divide this into little strips. I'm going to go a small little increment for theta. I don't know if I want to go that small. 4 or 5 of these. Okay. So I'm going to go theta from A equals to my first subinterval here. All right. Then I'm going to do a sector. So I'm going to make that circular, if you will. Then I'm going to sweep again another little bit of an angle. Okay. So that's going to give me, I guess that sector would be more like there. If I use the end point there. Then I'm going to go another angle. Sweep that out, and then I'm going to go to this one, finally, and get that. Okay. Something like that. But each one of those is a circular sector. So I know its area. Okay? Well, what is the area of each circular sector? Well, the area of each circular sector, call it A sub I, is 1/2 the radius, which would be whatever the radius is squared, times, now what's the angle? Well, that's where we get it's the change in the angle. That's our delta theta sub I. Or delta theta, yeah, delta theta sub I. Okay? So this approximating area, the approximate area would be the sum of all those. the sum of all these 1/2 RI squared delta theta sub i's. Okay? How can I get the exact area? Yeah, take it as a limit as n goes to infinity of all these 1/2 RI squared delta theta sub I. What is that? That's an integral. So that's the integral of 1/2 r squared d theta, right? Delta theta turns into d theta. 1/2 r sub I squared would be 1/2 r squared. Okay? Now, this, again, we're usually talking about an r equals f of theta. That's usually the way we want these polar equations to come. And so this is just going to be whatever the function is. So it's going to be plug in your f of theta, whatever it is. Square that. You're going to have to square it and then do the integral of it. So what's the area of a polar curve? Well, then you got your a to b. Theta equals a to b. That's how you do it. It's 1/2 your whatever your function is in terms of theta squared, and then do the integral. Okay? Not too bad, right? Well, let's start with an easy one. Find the area of r equals the square root, r equals 2 times the square root of cosine theta. And we're going to go from theta 0 pi over 4. Okay? Well, polar curve, the area is that. It's one integral of 1/2 f of theta squared d theta from a to b. So what is that here? It's the integral, this is my a, this is my b, 0 to pi over 4. 1/2 the f of theta, 2 squared of cosine. So you have to square that. So it's 2 squared of cosine theta, all that squared, times d theta. Well, like I said, this one's an easy one because of the square root right there. I'm squaring the square root. So that's 1/2 times 4 cosine, isn't it? Just be 4 cosine theta. Square those out. So that gets me down to 2 cosine theta. Yeah, that's just a straightforward antiderivative, isn't it? It's 2 antiderivative of cosine, sine. And I'm going from 0 to pi over 4. So that's 2 times the sine of pi over 4 minus 2 times the sine of 0, theta. Sine of pi over 4, square root of 2 over 2. Sine of 0, 0. The area is square root of 2. Now to see what area of the graph am I talking about? Let's draw the graph. With my calculator. Can I borrow your calculator, Josh? Thank you. Okay, so I am talking about 2 square root of cosine of theta is looking a lot like a circle, isn't it? Let's see, zoom in. Yeah. All right. So this is what we're talking about. More like an egg shape, I guess, but oval. Which part of the graph, though, am I talking about? Well, I'm going from 0 to pi over 4. So where would I be at 0? Plug in 0. You got cosine of 0, which is 1, so I'm at 2. So I'm right out here. R is 2. Pi over 4, and if you do a trace, that might be the easiest way. Just put in your theta as pi over 4. Hit trace and then pi over 4. It'll show you where you go, so it looks like I go from right here to right about here, which is about pi over 4. Yeah. Theta, yeah. These are thetas. Yeah. Well, it's where theta is pi over 4. It may not necessarily, this one it looks like, the pi over 4 angle, but it just depends. Now, if it was a 2 theta, that would be 2 times pi over theta. 2 times pi over 4, which would be, it would show up as pi over 2, wouldn't it? You see what I'm saying? So that would maybe sweep out more if you were doing 2 theta. But since it's just regular theta, it does look like your pi over 4. But anyway, so that's the area right there. Okay? So sometimes we'll have to figure out which part, or what the angle is that we want. What if I was wanting the whole top half of this angle, of this 2 square root of cosine theta? What would I need to go to get the top half? How would I get the area of that top half? Zero to pi? I want this area right here. Zero to pi? Would it be pi over pi by 2? Well, this gets 0. This is 0 to pi over 4, isn't it? Don't I need just pi over 2? I think so. I think so. And again, that's where you can get get the idea with your trace. If I go see where it is when I'm at pi over 2, yeah. If I go to theta as pi over 2, that puts me right there at that one. So if I go from 0 to pi over 2, I'm at that point there. And so that would, well, I guess it should be done over here. You see what I'm saying? Okay. So in this case, to sweep out the top half, I would go 0 to pi over 2. Yeah. Mm-hmm. Which, of course, your antiderivative would be the same. You just plug in the pi over 2 there. Let's see. That works out to be, that would still be, what was it? It wound up being just 2 sine theta. And so 0 to pi over 2. We'd be talking 2 times sine of pi over 2 minus 2 times sine of 0. That's still 0. Sine of pi over 2, it's 1, isn't it? So that area winds up being 2. Okay. find the area enclosed by r equals 2 times 1 plus cosine theta as shaded here. Remember, this is this turns out to look like this all the way around. I think. Let's make sure. 2 times 1 plus cosine theta. Kind of the spade looking top of the spade on a card anyway. Okay, where this is looks like 1, 2, 3, 4. But here's what I want though. I want this area right here. Just from this around. So again, it's figuring out the angles that I need. Okay? Well, what are you thinking? One way to do it, wouldn't it be to start at this one, because at theta equals 0, I would be right here. Theta equals 0, I would be at 1 times 1, 1 plus 1, which is 2, times 2 would be 4. So at theta equals 0, I'm at 4. So I'm right here. So how would I get it from here around to here? Yep. Start here at theta is negative pi over 2, and then go around here to theta equals pi over 2. Make sense? So the area there enclosed would be the integral from negative pi over 2 to pi over 2. Now what would be the inside part here? Well, it's 1/2 r squared theta, r squared d theta. So what goes here? Well, that's my r. So it'll be 2 times 1 plus cosine theta squared d theta. With me there? Well, that's going to be the integral 1/2. That would be square that would be 4. Square that. So 2 squared gives me 4. Square that, you got 1 plus cosine theta, 1 plus cosine theta. So 1 times 1 gives you 1. 1 times cosine gives you cosine. So I've got 2 cosine theta, and then cosine gives me cosine squared. And I can cancel that, so that's just 2. So I've got the integral of 2 times 1 plus 2 cosine squared. Negative pi over 2 to pi over 2. You want to distribute the 2? Might as well. At some point, we'll have to distribute the 2. So let's go ahead and distribute the 2. So it's the integral of 2 plus 4 cosine theta plus 2 cosine squared. Now what do you see as far as doing that? Just do them individually, right? So I'm going to do the integral of 2 d theta. That's going to be easy. Then I'm going to do the integral of 4 cosine theta. And then I'm going to do the integral of 2 cosine squared theta. D theta, of course. Well, the first two are easy. Antiderivative of 2 be 2 theta, right? That's an easy one. Antiderivative of cosine, sine. This is another story. Cosine squared. How did we do cosine squared? That was the double angle one, yeah. Use your double angle formula there. Remember what it was? 2, change the cosine squared by double angle. What was it? 1/2 plus 1/2 cosine 2 theta? Is that right? I think it's the way it all worked out. Does that sound right? Anybody believe that? Before I go on? Oh, I got it right here. Well, the good news there is with the 2 distribute there, got that 2 on the outside, so 2 times that will give me 1, and 2 times that will give me 1, so it's just going to be here 2 theta plus 4 sine theta plus the integral of 1 plus 1 cosine theta, cosine 2 theta. All right, well, let's see, right here. Let's go right here, or right up here. So I've got 2 theta plus 4 sine theta plus the integral of 1 is just theta. What about this one? The integral of that one. Little u substitution. U equals 2 theta. Du would be 2 d theta. So du over 2 is d theta. So that would be the integral of cosine of u du over 2. So that's going to be 2 theta. Actually, 2 theta plus theta would give me 3 theta. Combine these two to that one. Plus 4 sine theta. And that's just going to be cosine of sine, 1/2 sine of u, but u is 2 theta. Yep. And then I'm going to go minus pi over 2 to pi over 2. Okay, well, no biggie. It'll be sine of pi over 3 times theta, so it'll be 3 times pi over 2, plus 4 times sine of pi over 2, plus 1/2 the sine of 2 times pi over 2. So that's just going to be pi, isn't it? And then I go minus, plug in the minus pi over 2. So that would be minus 3 times negative pi over 2 plus 4, do it down here, times sine of negative pi over 2 plus 1/2 times sine of 2, so that would be sine of negative 1, wouldn't it? I mean negative pi. Okay. All right, so that's 3/2 pi. What's sine of pi over 2? It's 90. That'd be 1. That's 4. Sine of pi, back to 0. Yeah, that's 0. And then minus, well, we'd have minus 3/2 pi. Sine of pi, negative pi over 2. Is that negative 1? So that'll be negative 4. And that's 0.